Hi, everybody. So thank you for attending this talk, and I'm going to take a little bit of a contrarian view here. I know everybody is enamored with large language models, so my contrarian view is, what about small language models? Right? What do we do about small language models that might, in certain cases, be a better fit for some of the enterprise work that most of us are engaged in? So don't get me wrong, large language models are great, right? I mean, they are flexible, they are powerful, they have emergent capabilities that we don't even know of. But all this power comes at certain disadvantages. The first disadvantage is cost. So for those of you that dabble in this, the Llama paper, Llama is a large language model from Facebook. The Llama paper informs us that it took them 21 days to train a model. The model consisted of 65 billion parameters, and the training was done on 2,048 NVIDIA A100 GPUs. Each GPU had 80 gigabytes of VRAM, or video RAM. So essentially, we are taking a look at 163 gigabytes of VRAM to train a model. The cost of all this, about $4 million. So clearly, this is outside of the budget of many enterprises, right? So cost is one thing. The second is size. I mean, these are large language models, right? So if I take a 65 billion parameter model, I definitely cannot run it on one NVIDIA A100 GPU. I would need many of these GPUs just to run one model. The third disadvantage is more interesting to me, and that is around general purpose. These models are designed to be general purpose so they can fit many different business verticals. But one pattern that we are seeing emerge is that enterprises are taking these general purpose models, they are then constraining them to their specific business vertical. So you take this powerful model, and then you constrain it and adapt it to your business vertical. So that begs the question, why not small language models, right, which you can train specifically for that purpose? So take a small language model, take a very small language model, something trained on maybe 30, 40, 50 hours of audio, and it's agile. You achieve efficiencies of scale because you can load many of these on your A100 GPU. So that's my focus here. And I'll try to, I'm not going to go through all of these. We are at booth 500, so please stop by, and I'd love to talk to you and hear your views about the advantages of large language models as well as small. So let's take a look at a specific vertical that many enterprises use, ASR, automatic speech recognition. So this is where text gets converted to speech. Many of the enterprises use this, so let me try to give you a little bit of a flavor. So we took a model, and we used Caldi to train an ASR model. Caldi, for those of you that, again, are in this domain, is the best of breed open source toolkit to train ASR models. So we took a model, or we took some data, and we trained our own model. Our model required 75 hours of audio compared to 680,000 hours of audio that Whisper used for training. Training on Whisper, the paper is not clear. It takes something to the order of weeks to train it. Our model took less than 8 hours to train on one NVIDIA GPU. Whisper takes anywhere from, depending on base or large, about 1.5 gig of VRAM to about 11 gig of VRAM. We take half a gig of VRAM. So you can look at the efficiencies of scale where you take one GPU and you can run multiple models here. The hours of data, for instance, if you take a look at this, it's almost 4 orders of magnitude less data to train. At a much better word error rate, we get a word error rate of about 9% compared to about 17 to 20% for Whisper. And word error rate, for those of you that are in this domain, know is very important because all of your downstream processes, all your back-end computing depends on word error rate being as low as possible. We take a look at the decoding time, and you see at least an order of magnitude performance. If you take a look at the large model, a 2-second audio takes almost 700 milliseconds. We do it in 7 milliseconds. 7 milliseconds, right? So my point is that it's not the case that I'm not knocking Whisper. In fact, we use Whisper in a lot of our processing. I'm not knocking Whisper. I'm just trying to make a case that you don't necessarily want to use a chainsaw to open a can of tuna, right? You want to use the right tool for the right job. And with these small models, you can get efficiencies of scale at a fraction of the cost that it'll take to run that large model. So we've actually, we have what we call micro models. So we have a digit model that can recognize digits from 1 to 5 with a very low percent rate. As you can see, a word error rate of 1%. We also have a Spanish model that we trained. I know my time is almost up, so I'm going to wrap it up. We have a Spanish model that we trained, and that shows us a word error rate of about 14%. A commercial ASR engine was giving us a word error rate of about 33% on this. So clearly, these small bespoke models are important because you can load them into memory, you can unload them, you can load multiple of them into memory. And I'd like to introduce our FreeClimb project. FreeClimb is a programmable telephony AI platform. You can create call legs, remove call legs, record. You can load models. You can tell models to, OK, get the transcript and send it here. So it's used to integrate a lot of the application logic that you see in enterprise businesses. We are at booth number 500. So please drop by. I would love to talk to you, learn more from you, and also to tell you what we've done with these bespoke models or these micro models. So I do not know if you have time for questions or how you work it out, but
I wish we did. Come find Vijay here or find them in the booth 500 for questions. Let's give it up for Vijay.
Thank you.